Welcome back again to the bench. We're doing a little review from last week's video where we showed you how to use this circuit to power this mini circuits double balanced mixer and drive a new electric. Actually works pretty good. It's not a real up converter, which is what we were demonstrating last week, but it is, it does work pretty well, but there is a lot more to an up converter than just up converting frequencies. For example, you really need to do a lot of filtering. But I had a request from a viewer to get a look at the schematic for the circuit. And it's really very simple, so I thought I'd just do a follow-up video and show you that now. It's just a crystal oscillator. We're using a garden variety 2N3904, and the circuit is powered by 12 volts starting at the top of the schematic here, which is really not drawn in schematic form. It's really drawn in just kind of more like layout form, but anyway, the 12 volts is decoupled by this 47 ohm resistor and a 0.1 cap. This toroid that I did not know the value of last week, I actually measured, and on the short wire wrap side, which I'm calling L1, it's 293 nanohenries. The other side's 1.274 microhenries, and it appears to be wrapped on a T50-2 toroid. I don't know if you can tell. If you look up here in the circuit, though, maybe if I can focus that, you can see that underneath those goldish enamel wire wrappings, it looks like a red toroid. Anyway, you can take my word for it, it is. So yeah, T50-2 looking toroid, and it's only supposed to be good for up to 30 megahertz, and here we're using 33, a 33 megahertz crystal, but it works pretty good. I just made that little crystal socket out of some header. It's actually a header socket, header jumpers, header, whatever you call those. So yeah, it works pretty well. Oh, and then the capacitor that I'm calling C2 here, which is on the emitter of the transistor, is 10 picofarad. But I did experiment with some other frequencies earlier, some other crystals, and found that you can use like 100 picofarad there and do some lower frequencies. Okay, so now there are the pinouts for the 2N3904, and if I can do it and work the camera at the same time, I'm going to turn the page and we'll take a look at the buffer stage schematic. Come on, here we go. So yeah, it's also a 12 volt circuit decoupled by the 10 mic, and we've got a 100K potentiometer coming here to the base, which is where the input comes in. I'm sure that you could use a lower value potentiometer and do just as well. It's just a 2N4401 because that's what I had close to hand in the junk box. And I'm pretty sure better, or I should say a transistor rated to work at VHF frequencies would do better. I don't know what the frequency of transition is for a 2N4401, but I just feel like I would get better current amplification, better voltage amplification if I had a stronger transistor there. Through experimentation, I found the output was best taken at the emitter, and this is just a little 1K resistor and a couple of 100 nanofarad caps in series. Now, that's not a cap voltage divider. I just twisted these together because I was experimenting to find the correct value capacitor. So you could have this value and just use one cap, and the circuit will work just the same, or it should. So that's it. Yeah, I'll put a link in the show notes to the previous episode so that you can see a demo of this all working, but not bad, not bad. I mean, if you're thinking about it from a money investment point of view, and you think about you got 18 US in a new elect RTL SDR and a double balanced mixer, you know, you don't have to have this fancy of a one. You could get a really cheap $15 one and it would work just as good. And I say cheap, and it's a Mini Circuits SBL1, which you can buy off eBay for 15 bucks, is a great mixer. But anyway, so, 30 bucks US plus whatever a crystal and some transistors costs. It's not bad money to be able to listen to the entire ham spectrum, 0 to 30 megahertz, and that's not even counting the new elect without this goes up to, I think it's 1.7 gigahertz. So DC to daylight for under 40 bucks. There you go. If you build a circuit, I wish you luck.